Okay, so we have this question here. It says use Cramer's rule to solve the following. Okay, so these are simultaneous equations. Now, unlike the previous ones which we're looking at where there's only two variables, x and y, we have the third variable here, z. Okay, so we can't use substitution or elimination method. All right, so we're going to have to use Cramer's rule. Okay. So now the first thing that we need to do, okay, is we need to make sure that all the equations are in a certain format, okay, where we have x, y, then z. Okay. As we can see, equation 1 is in the standard format, and equation 3 is in the standard format. So equation 2, we need to rearrange it, so we put it in the standard format. The reason why we're putting it in the standard format is because we're going to need to form some matrices with these equations. Okay, so we'll take this y over the equal sign, so it becomes 2x minus y. So this is a positive y here, comes minus. This negative z also, we take it over the equal sign, plus z, then we equate it to 0. Okay, so here the equation of x plus y plus z equals 3. Then here our third equation, negative 3x plus 5y plus 7z equals 7. Okay, so now all the equations are in the standard form. Okay, so now we can go ahead and use Cramer's rule. So the first thing that we need to do is we need to form the coefficients matrix. Okay, the coefficients matrix. Just hold on. Yes, so we need to form the coefficients matrix. Let me just do a quick Airtel transaction, colleagues. Just hold on. Let me just do a quick Airtel transaction. Okay, so we continue. So the coefficients matrix, we are going to look at the coefficients for x, y, and z. All right. So if we look at equation 1, let me even label the equations here. This is equation 1. This is equation 2. This is equation 3. Yes. So in equation 1, the coefficient of x is 1. In equation 2, the coefficient of x is 2. In equation 3, the coefficient of x is negative 3. Now we go to the coefficients for y. Equation 1, the coefficient for y is 1. Remember, the coefficient is just the number in front of the letter. So when you say a letter by itself, there's an invisible 1 there. This negative y, the coefficient is negative 1. This, for equation 3, the coefficient is 5. Then we go to the z. In equation 1, coefficient of z is 1. In equation 2, coefficient of z is also 1. In equation 3, coefficient of z is 7. Any questions before I move further? Okay, then another matrix that we have to form is for the constants. Okay, these answers for the equations here. Okay, for equation 1, it's 3. Equation 2, it's 0. Equation 3, it's 7. So these matrices, we're going to use them once we start operating. Okay. So step 1, you get the overall determinant. Okay. So here we're only going to be dealing with the coefficients matrix. Now, once you start getting the determinants, this is the pattern that happens here. When you write down the matrix, the first two columns, okay, this column and this column, the first two columns, you write them outside. 1, 2, -3, and this one 1, -1, and 5. Once you've done that, you're now going to start multiplying the numbers in a diagonal form. So as I said, if I'm multiplying, the diagonal is going southeast like this. If I'm multiplying like this is what we call the leading diagonals. Okay, where we're multiplying southeast. All right, so let me show you. You start with the topmost number on your left. 1 times -1 times 7. Okay, 1 times -1 times 7. So in the exam, you have to put it like this. Okay. When you're multiplying these diagonals, you have to put the tabulations also there. Okay. But in this case, we'll just multiply, we get the answer. We just multiply, we get the answer. But you have to show your workings in the exam. All right. So 1 times -1 times 7, we get -7. We go to the next diagonal. 1 times 1 times negative 3. Okay, 1 times 1 times negative 3. What do we get? We get negative 3. So you put plus negative 3. Okay. We put here plus negative 3. Okay. Then the next diagonal. 1 times 2 times 5. That gives us 10. Any questions? So negative 7 plus negative 3. This positive and negative make negative. So it's like negative 7 minus 3, you get negative 10. Negative 10 plus 10, you get 0. Now we're going to be multiplying. The diagonals will be moving northeast, trailing diagonal. All right. So you go at the bottom left, you start from the bottom left. Negative 3 times negative 1 times 1, we get positive 3. Plus 5 times 1 times 1, that gives us 5. Then 7 times 2 times 1, we get 14. So you put plus 14. 3 plus 5, 8. 8 plus 14, we get 22. So for our overall determinant, it is the leading diagonal minus the trailing diagonal. All right, so it's going to be 0, this 0 here, minus this 22. So our determinant is negative 22. Any questions? So in the exam, colleagues, have at least a black and a blue pen and a pencil, so that when you're multiplying these diagonals, if I multiply, then you can erase. Okay. We move to step 2. We get the determinant for x. Okay. Good evening, madam. How are you? Mm. Yes. Let me show you how it should show in the exam. Have you seen? So with your pens, you indicate how you're moving like this. Once you indicate the diagonal, then you put the tabulation down there. Okay. But the arrows, you can still leave the arrows there. If you want, you can still erase them. It's up to you. Okay. The marker will understand. Okay. They know this technique, so they will understand. Okay. And make space. Okay. Because if you put the matrix close, when you're making the diagonals, you might make an error. Okay. And this question, do it last. It should be one of the last questions you do. Okay. Because this question takes time. Okay. Any other question before we move to step two? Now, moment we start getting the determinants for x, y, and z, this is where this matrix will come in. This constant matrix, this 307 here. This is where this matrix now comes into effect. So, this is what happens. When you want to get the determinant for x, when you're making your matrix, okay, put matrix here. The x column, you're going to replace it with this 307. Okay. This 307 is going to replace this 1, 2, negative 3 column. Okay. So in our x column, we'll put 307. Our y column stays the same. 1, negative 1, and 5. And our z column 1, 1, 7. Okay. The z, the y and z column stay the same. Okay. But the x column is the one that changes because we're getting the determinant for x. Okay. Because in this Cramers rule technique, you're just getting determinants. It's all about getting determinants. Okay. And then, as I said, once you've made the matrix, the first two columns, you bring them outside. So we start with the leading diagonals. Okay. If you want, you can start with the trailing, whichever. So you go to your topmost number on the left, 3 multiplied by negative 1 multiplied by 7. We're going to get negative 21 plus 1 times 1 times 7. We're going to get 7 plus 1 times 0 times 5. We're going to get 0. So negative 21 plus 7, that gives us negative 14. We go to now the trailing diagonals. The bottom number to your left, 7 multiplied by negative 1, that is negative 7, multiplied by 1, you still get negative 7. Plus 5, there's 5 here, multiplied by 1, multiplied by 3, we get 15. Plus 7 times 0 times 1, this will give us 0. Negative 7 plus 15, that gives us plus 0, that will give us 8. So our determinant for x, remember it's leading minus trailing, so you put the negative 14 first, negative 14 minus 8. Negative 14 minus 8, that gives you negative 22. All right, so any questions before we move to the next step? I hope we're seeing the pattern now. Once you get the pattern, because the pattern just repeats itself, just repeating itself, repeating itself. Okay. Step 3, get the determinant for y. So since we are getting the y determinant, it means when we make our matrix, our y column is going to be substituted with 3, 0, and 7. Okay. So whatever determinant you're getting for the letter, just know that its column will be replaced by the constant matrix. Okay. So in this case, it's this 307. So our x column stays the same, 1, 2, negative 3. Our z column stays the same, 1, 1, 7. All right. So as I said, always you write the first two columns outside, 1, 2, negative 3. Then also here, 3, 0, 7. So again, so we continue with the same process. Multiply diagonally. Start with the leading diagonal. 1 times 0, that is 0. 0 times 7, that gives us 0. Plus 3 times 1 times negative 3, that will give us negative 9. 3 times 1, 3. 3 times negative 3, negative 9. Plus 1 times 2 times 7. 1 times 2, that is 2. 2 times 7, that is 14. So we're going to say 0 plus negative 9 plus 14, that gives you positive 5. Next, we go to the trailing diagonals. So it's that negative 3 multiplied by 0 multiplied by 1. That will give you 0 plus 7 times 1 times 1. That will give you 7. Then the next one, this 7 here, 7 times 2, that is 14. 14 times 3, that is 42. Okay. So you're going to say 0 plus 7 plus 42. That gives us 49. So the determinant for y, remember, leading diagonal. So this number at the bottom. Always remember, the one at the bottom comes in front, okay? So you say 5 minus 49. That will give us negative 44. Okay, the final step, we get the, okay, yes. Negative 9 plus 14. Yes, at the bottom here. Okay, so we got the final step where we're getting the determinant for z. I think this is step 4. So just remember, you get overall determinant, determinant x, determinant y, determinant z. Okay, that's the process here. Okay, so our z column now is the one that's going to be replaced by the constant matrix. That three. Mhm. Sure, sure. It will be wrong. Always start with the one at the bottom here, the one for the leading down. Do not mix up the two. Yes, if you mix up the two, you get a wrong answer. Just follow the format. The number that you get at the bottom, you put it first, then the one on top comes second. Okay? Yes, leading diagonal minus trailing diagonal. Sure, sure. All right. What was I? Yes. So the Z column we are replacing with 3, 0, and 7. The X column still the 1, 2, negative 3, The y column is still 1, negative 1, 5. And as I said, always put the first two columns outside. 1, 2, negative 3. And here, 1, negative 1, 5. Mm-hmm. Whenever you're finding the determinant for that letter, this column must be replaced. Yes. So if you notice in A, when we were getting determinant for X, the 307 was in the X column. Determinant for Y, the 307 is in the Y column. And determinant for Z, the 307 in the Z column. Yes. And remember, this changing column starts when you start getting the determinant for X. Right? When we did the overall determinant, it wasn't there. Okay. So remember that, colleagues. Okay. The, yes, the constant column is only going to come in effect when you start getting the determinants for the letters. Okay. Is that okay, madam? Have I answered your question? Okay, you're welcome. Okay, so we multiply again diagonally. 1 times negative 1, that is negative 1, times 7, that gives us negative 7. Plus 1 times 0 times negative 3. So we get 0 here. Plus 3 times 2, 6 times 5, 30. So negative 7 plus 0 plus 30, you're going to get 23. Go to the trailing diagonals. Negative 3 times negative 1, that is positive 3, times 3, that's when we get positive 9, plus 5 times 0, times 1. Is that a question? 0. Plus 7 times 2, that is 14. 14 times 1, that is 14. 9 plus 0, 9 plus 14, 23. Determinant for Z, leading diagonal, this one at the bottom, 23, minus, hold on, minus 23. So 23 minus 23, what do we get? 0. Okay, so that's our determinant for Z. Yes, yes, is that a question? Was that a question? Okay, now we can find our values of X, Y, and Z. So to get the value of X is the determinant of X divided by the overall determinant. Our determinant for X, negative 22. Our overall determinant also negative 22. So it's negative 22 divided by negative 22. So our value of X is 1. Get the value for Y, the determinant for Y divided by the overall determinant. Our determinant for Y is negative 44. So negative 44 divided by our overall determinant, negative 22, gives us positive 2. Okay. So our value for Y is 2. And our value for Z, the determinant for Z divided by our overall determinant, 0 divided by negative 22, that gives you 0. So these are our answers. X equals 1, Y equals 2, and Z equals 0. And we can check to see if these answers hold true. Okay, you can pick any equation. Okay, equation 1, we can use equation 1. X plus Y plus Z equals 3. So X, we said it's 1. Y, we said it's 2. Z is 0. So 1 plus 2 plus 0, that gives you 3. Okay, you can check your answers to, you just pick any equation that you want and plug in the values to see if it holds true. So in this case, it holds true. We've plugged into equation 1. 1 plus 2 plus 0 equals 3. Any questions?